I'm going to go through a chi-squared analysis using the program JMP. This is an example that was used in another video where a chi-squared was done by hand. And in this example, we're looking at the preference of chickadees for certain types of trees. And so in the Pacific Northwest, there's two kinds of chickadees that are common in the lowland areas: black-capped chickadee and chestnut-backed chickadee. And they're often seen foraging together in flocks, but a research question might be, is one species preferring a type of tree over another? And we're keeping that to two big categories: conifer tree or deciduous tree. And so go out, collect a data set, and in that data set, the observations include what species. BCCH is black-capped chickadee, CBCH is chestnut-backed chickadee, and then the tree type. So for each observation, I'm noting what species is being observed and what type of tree it is foraging on. And so there's this data set, and you can see we have this list of observations with different species and different tree types. Okay, and decent sized data set, 131 observations of these birds foraging. Okay, so I want to run a chi-squared test. I can actually import this data into JMP or simply copy paste it into JMP. I'm going to open up JMP now. Okay, and now I'm opening a JMP new data table, and I paste with column names. It's important to paste with column names so that JMP understands the way the data are structured. And I can see that JMP has read my data correctly because it's considering each one of these columns to be two different types of data, or two different data fields, bird species and tree type, and they're both categorical data. And that's what a chi-square test is good for, an X and a Y that are categorical. So now it's as simple as going to the Analyze menu and selecting Fit Y by X. And so because I have two categorical variables, it's going to do what they call a contingency or chi-squared option. And in this case, you may question, is bird species the predictor variable and tree species the response variable, or vice versa? Well, it's most likely that tree species or tree type is influencing what the birds prefer. But at the end of the day, you're going to get the same result in this type of test, regardless, when it's a two-way like this and it's a chi-squared. So I put tree type in my independent variable, my X, bird species in the Y. I click OK, and this is what the output looks like for a chi-squared test. You get this bar chart comparison, and basically you have species as these two different colors, red and blue. And so red is black-capped chickadee, blue is chestnut-backed chickadee. And then these two bars on the x-axis are conifer and deciduous. And the width of those bars tells you something about the sample size in each observation field. And then you get a contingency table that actually has numbers in it similar to what exactly to what you would compute if you were doing this by hand using the homogeneity of proportions test. It gives us our sample size, our degrees of freedom, which is numbers of rows -1 times numbers of columns -1, so it's 1 in this case. What they call the log likelihood probability, which is a probability value in an R-squared. You also get down here two types of chi-squared test results. And so these are results that you get by adding up these functions of observed minus expected divided by observed values. And there's likelihood ratio, and then there's Pearson, and they're very, very similar. As you can see, the chi-squared values are very similar, and similar to another video in which we did this by hand. And here is the probability value. So the probability value in this example is 0.37. That is a number that's much larger than 0.05. There is no significance associated with this test result, but we do have the complete test results here. And so that is chi-squared and JMP.